Hi, everybody. My name is Tolga Tarhan. I'm the Chief Technology Officer for Rackspace Technology and joined today by Amir Kashani, our VP of Cloud Native Development. We're going to talk about lessons learned with serverless application development. So serverless allows you to deploy and develop at cloud scale. So the goal here is faster time to market and faster innovation with reduced costs and improved reliability. Now, that sounds like the marketing speech for every new product out there, every new developer tool out there. But really the difference here with serverless is the ability to focus on the business value and not the infrastructure. So instead of writing a bunch of code that does things like runtime management, configuration management, that does sort of just like the scaling up and scaling down, or the long-running applications that have to have lots of lifecycle maintenance components, we can eliminate all that kind of undifferentiated code. And the only code we have to write is our business logic. And we wire that business logic to events. Those events can come from the web, they can come from timers, they can come from other queuing systems, they can come from a bunch of different sources, including sources that we can just dream up on our own. And so by doing that, we're really focused on from the time a request comes in to a time we respond to that request or that event. How are we going to do that? What's that kind of core business logic going to be like? And in doing so, we really do focus developer attention and time. And this is really happening all over the industry. It's happening with automation frameworks. It's happening with web backends. It's happening in data processing environments. It's happening in AI. In fact, a lot of the voice-enabled applications are powered by serverless technologies, as it's the primary way to integrate with those technologies. And it's happening across all kinds of industries as well. So from logistics to commercial and consumer products to industrial, travel, healthcare, and really you could probably list just about any industry we've run into a serverless use case. And when creating serverless applications, or really when creating any application in our practice, we start from a serverless first approach. So we examine how far can we take our serverless infrastructure with not just the compute layer with Lambda, but with message buses, databases, API layers, storage, and so on. And this is really important because the more you can adopt the serverless services, the easier the entire infrastructure is to scale. So for example, in a serverless environment, you're only concerned about how much resource it takes for a single event or a single request. As soon as you start introducing non-serverless components, however, you now get back to sort of traditional scaling challenges that say, hey, what's the total aggregate throughput I need, the aggregate compute or memory I need across all my events, all my requests. And so we want to avoid that kind of disconnect between the two modalities of scaling. And the litmus test here is if the scaling metrics are not compute and memory, you're probably using a service that fits in the left box here, in the kind of serverless box. As soon as you're talking about memory, CPU sizes or quantities, you're really not in a serverless model anymore. You'll have to scale that part of your infrastructure to handle the aggregate load, while the serverless portion scales automatically. So as a result, what we want to do is we want to start every conversation with, can I fit this into the serverless services? Can I use Dynamo and SQS and SNS and all these other services that don't scale on those memory and CPU parameters? They just scale on things like message throughput and other metrics of that sort, which is abstract enough that you can focus on your business need and not on underlying infrastructure to support it. Where you can't do that because the services don't have the capability you need, maybe you need a more traditional relational database, maybe it's a vendor that you have to support, we want to move to PaaS where we can. By adopting the platform as a service services, we at least get a management plane that takes care of a lot of the undifferentiated portions, and we can focus just on our business logic still, our business needs still, but we'll have to manage scaling a little more carefully. And only when there's no platform as a service offering do we then look at infrastructure offerings. And so on this diagram, you want to push to the left as much as you can, to PaaS where you can't do that, and to IaaS only where you have to. So now to tell you a bit more about this and about the lessons that we've learned along the way, here's Amir Kashani from our Cloud Native Development team to tell you more.
Thanks, Olga. So I'm excited to talk to you a little bit about our lessons learned doing serverless. We've been at this since probably before we should have. We started our first serverless app in about 2015 or so. So Lambda had been out for a couple of years. API Gateway had just come out. And it's no doubt that we've learned some lessons along the way. So we'd like to share some of that so that you avoid some of the pitfalls and you have the best serverless journey as you can. So a couple of categories we want to talk about around developer workflows. So while it's true that programming languages don't change when you go to serverless, you can still use .NET, Java, Node.js, Python. A lot of the workflows and processes and tools and frameworks do change. And if you're not really familiar with those, that's the area where we found developers can really get hung up. So things like code organization, testing strategies, deployment, and basically that process needs to be understood and thought through. So code organization. So we see two major categories of mistakes when looking at how developers organize code in a serverless application. The first one is that they take the notion of Lambda functions and the word functions a little too literally, where everything is placed into the Lambda function handler itself. And we forget about all the architectural principles that we've been following for the last generation of developers. So there definitely is a balance there. The flip side we see is we end up with something called a monolithic Lambda, where all of the code is plugged into a single Lambda handler. And now you've really kind of abused the Lambda runtime, abused the notion of a micro-function environment to deploy your entire application. There's definitely a sweet spot there. And part of that is keeping in mind, again, the patterns that we've all been accustomed to, years past. So here's what, in our mind, a typical handler should look like. The primary point of the Lambda handler is to take the information provided from the context and the event, and then process that, and then pass that through some back-end service. So in this case, we're having a simple, imagine kind of a form where you're looking up a user's email address. All we're doing here is taking the email address from the context and then invoking a service, in this case, user service find user by email, which does all the interesting work. And then we formulate the response. The important thing about this is it keeps the Lambda handler relatively uninteresting. There's not a lot of logic going on here, which is going to be important when we talk about testing strategies later. But beyond that, it means that beyond the function, the handler itself, the rest of your code isn't dependent on the Lambda runtime and environment, which means it's easier for developers to reason over, they're more familiar with it. And if there are ever changes you want to make to the approach of how you're deploying it, it minimizes those changes. So next up is code testing. So testing, and by testing here I mean unit tests, integration tests, and any sort of automation, or really it's more important than ever. Because to be able to test your functions end to end, you have to deploy it to a cloud environment, to AWS. That we found that if developers don't think about unit testing and testing first, they end up spending a lot of cycles with just the deploy test process. And you don't really want to do that, right? You don't want to spend all your entire day waiting for functions to deploy and infrastructure to spin up as fast as that may be. So you should be taking, ideally a test-driven approach to your Lambda and your serverless development. Well, if not, at the very least, focus on unit tests, run those locally, make sure that they run locally, mock out services like DynamoDB to the extent possible, and there's some really great utilities you can leverage there, and minimize the number of times you have to deploy to AWS to test your code. So really, this is about speeding up the development lifecycle by leveraging testing. So here's what something like that might look like. If you recall the Lambda handler that I showed before, it was calling this service called find user by email address. That's shown on the left here. Now this is a bit of a contrived example because all it's doing is calling a repository method, so another pattern that exists in enterprise Java and .NET, right? This notion of your handler, your incoming code, then a service layer and a repository data access layer. So you're seeing that represented here. So all this is doing is invoking that repository layer and then doing an in-memory filter for the email address. So again, a bit contrived. You'll really do this in a database, but serves as an example. What this now allows us to do is on the right-hand side, we're using a standard unit testing framework, in this case Mocha, to run a whole bunch of tests against that environment, or that method rather. So we're able to make sure that we're finding the exact matches, partial matches and what have you, and all of the interesting business logic is encapsulated behind that Lambda handler layer, which means it's more testable and again less dependent on the Lambda environment, which means you have to deploy less often.
Okay, let's talk about deployments. in a serverless environment, even more so than typical infrastructure, deployments are error-prone and they're hard. It's because of all the moving pieces of a serverless application. Take a look at this. A serverless app could very easily have Lambda and Kinesis, and Dynamo, and AWS IoT, and API Gateway, and it could have many instances of those things. It could have dozens of SQS topics or a whole bunch of SNS topics. And in doing that, you end up with a lot of individual resources to configure. And when you multiply that between dev and staging and production, it's a huge number of permutations and very hard to manage. And so it's really important that we get automation right from the beginning. Now, if you want to do this automation yourself, this is what the CloudFormation might look like for the simplest of deployments. And this isn't even the whole thing. It kind of scrolls off the bottom here, right? It's a lot to write by hand, and it's a lot to maintain by hand. So as a result, there are tools that simplify this. There are tools that give you a more typical development environment. They reduce the kind of configuration and automation burden to a minimal amount, and they generate the resulting CloudFormation. This is great for developers to be able to self-maintain the event hooks. So a developer can simply say, here's a new event type that I want to attach, here's a Lambda to run, and all the kind of wiring of that is done automatically by these frameworks. The two most commonly are called Serverless Framework, which is an open source community project, and SAM, which is an AWS sponsored project. We're going to look at Serverless Framework. It happens to be the one we use the most in our practice. So in Serverless Framework, we combine a YAML configuration file, but a very simple one, I'll show it to you in a second, with pretty much any supported language for our actual code, and with the tool itself. The tool converts serverless YAML plus our code into a package that can be uploaded to Lambda and the resulting CloudFormation required to deploy it. So it generates basically a code package and CloudFormation, and then kind of manages the actual deployment of the CloudFormation. This lets us represent sort of the entire application in a YAML file, and it's really broken up into four components. There's the actual service itself, which is the kind of configuration for the overall combined service. Then there's a definition of each function, and then a configuration of what events that function maps to. And then finally, you can add in other CloudFormation resources that are not automatically generated, but kind of maybe you need a DynamoDB table, maybe you need an SQS queue. Those can be added as just raw CloudFormation to the end. Here's a very simple example for a Node.js, and you can see we're defining just a very simple service here, the single function mapped to a single handler, mapped to a single event that happens to be an API gateway event for a web request to the hello path. And after this is deployed, there will be an API gateway, there will be an endpoint and a mapping for hello. You'll be able to hit that URL, and it will invoke this hello handler dot handler function. This allows developers to write code exactly the way they're used to and just package it up at the end. Now, here's some tips and tricks. Think about how you're going to instrument from day one. So you could integrate X-Ray or a number of third-party performance tools here to figure out how you're going to do tracing and traceability across your Lambda. There's going to be more distributed kind of metrics and logging than you're used to. Being able to collect all that is really handy, which leads us to CloudWatch. Consider creating CloudWatch dashboards and use CloudWatch logs to get a single pane of glass. You can also push this data into Elasticsearch, for example, if you want to use sort of more open source tools. And then don't forget that CloudTrail, AWS Config, CloudWatch itself, IAM, KMS, these are all going to be key tools for governance, configuration, monitoring. So these are key parts of a serverless application. And then one more set of tips and tricks. Externalize your configuration. It's going to be really, really important that as you deploy the same code to dev, test, production, that your configuration is externalized, that you use things like Systems Manager or Secrets Manager or environment variables. You can manage these through Serverless Framework to actually import those external configurations, inject them into your functions, typically as environment variables. But it's really important to consider that from sort of day one. You need to then design your whole solution to run in parallel environments as well. So if you think about every developer having their own environment and deployed to the same Amazon account, but each with a prefix, for example, in front of all the resource names. It's really important to think about how that's going to work from sort of the first point of development. So you might prefix every table with the name of the environment. You might prefix every topic or queue the name of the environment. Come up with a convention here and stick to it all throughout. This will let you deploy multiple environments in the same Amazon account, which will really help you when you're managing sort of development processes. Don't forget to use local deployments for testing. So your unit tests should run locally. Your unit tests should not require a deployment. It's okay if your integration tests, or obviously if your sort of human point and click testing requires a deployment, but you need at least unit testing to happen locally to be able to test your code without waiting for a deployment cycle. And then don't forget to keep an eye on the dependencies between your services, your code and the services that you use. You got to consider things like permissions and monitoring and everything with all your downstream dependencies.
So we've seen some of the specific examples of areas where developers can get caught up, and some of the lessons we've learned, we want to make sure that we pass on to you. Beyond that, I do want to touch on some general challenges that we've seen in an ecosystem and areas where a partner might be able to help. So we've touched on developer workflows quite a bit, testing strategies, how to organize your code, how to deploy it. But beyond that, we also see operations teams struggle with the notion of a serverless-based architecture. You imagine a traditional application might have a monolithic WAR file if you're doing a Java application. And it's pretty easy to reason if something goes wrong where the problem may lie. But if you think about splitting that up into microservices and those microservices being composed of dozens or hundreds of lambdas, you can start to see pretty quickly how getting visibility into your full application, your full system might be a challenge. So there are new tools, new processes, new systems that need to be deployed along with just the enablement of operations teams to have full visibility into a system. Lastly, the other one is with challenges with security teams. Security teams are still in some ways adapting to the notion of an AWS or cloud environment and how to enable developers and how to limit what developers may do to limit their exposure and ensure compliance with privacy regulations or rules internally and governance, things like that. So serverless really upends that because it's a very different workflow. So it's important for security teams to understand the mechanisms, understand the shared security model, to understand the tenancy and model of a serverless environment and how AWS protects one tenant from another and isolates code, and then really come up with a guardrail approach so that developers and builders aren't limited in what they can do because security has sort of old policies that are trying to adapt to the cloud. And so Rackspace Technology comes in and helps with, we're helping our customers with a serverless transformation. So we're helping customers build brand new cloud native applications, and that's from ideation and user experience design all the way to development and deployment, and really thinking about the end-to-end lifecycle of an application and the complexities that may come with it. The goal here is to focus on our customer's use case. So we do want to leverage serverless and managed services as much as possible. Next up is modernization. So as the last generation of applications are hitting their sort of end of life and it's time to invest in a technology retooling, we're really encouraging customers to consider using serverless as much as possible. So we're taking customers through a incremental modernization approach where through workshops and design sessions, we're breaking up monolithic applications, identifying those bounded contexts, and coming up with an approach that leverages serverless without the pitfalls of processes and workflows changing. And last is managed services. So kind of tying back into that operational visibility, but as well as the security, through offering our managed services, we can work along your teams to keep the lights on, as it were, deal with any issues that may arise, and really kind of offload some of the challenges of operating environments in a 24/7, 367 sort of environment that we live in. And fundamentally, our approach is to work with our customers. So through all this, we're working alongside development teams and operations teams to enable them so that, if they want to take over or they want to, have the expertise to run future workloads, they're able to do so. I'd like to touch on a few customer use cases. So first is a customer that was building a digital therapeutics platform. First, they were launching a single device, and the idea with this device is to improve patient outcomes by monitoring adherence to a prescription and general usage of this device. But longer term, the goal is to build a system that can ingest this data, process it, and improve the overall healthcare. So this particular company had been at this for about 3 years with other partners. They took a more traditional approach, and they didn't end up getting anything into production. And the clock was ticking as their device was about ready to hit market. So they came to us and asked for our approach, and we came with a serverless first approach, and we were able to build this system shown here in about 8 months. So it's fundamentally serverless. So you see there's almost no instances in sight here. And we did so in a highly regulated environment, which was unique because, as I mentioned before, security and governance teams, in some cases, are struggling with the notion of how serverless fits in. So we were able to work with those teams, the privacy teams, QA teams, to explain the system, to put guardrails in place, and to ensure that patient privacy was held to the utmost standards. Next, this is one of my favorite ones. This is a company that does fleet tracking and logistic applications in East Africa. So they're a fast-growing company, and like most small companies, they initially built their entire platform off of spreadsheets. So they quickly outgrew it, which is a great thing. But they wanted to basically rebuild this spreadsheet-based approach without stopping their business, which meant that we wanted to add new functionality and features quickly, test them, get them to the users without a long deployment and test cycle. So we recommended a serverless approach again, and we were able to build this application for them incrementally by adding functionality over time. So two major parts of this application shown here. One is a web application. This is used by fleet managers who are responsible for looking at shipments and tracking and kind of seeing how they're progressing against the order. And then really interesting is there is an Android application used by the drivers themselves. This allows them to check in at various key milestones within the journey. So whether they're at a way station or whether they're at a customs checkpoint, they're able to check in so that the fleet managers have full visibility. Very simple app to use, designed for low-power devices, and uses serverless for all of that. We also incorporated IoT, which many people don't realize. This, in my opinion, is part of the serverless suite of services because it is not any infrastructure that you have to manage. But we were able to use the IoT service here for real-time notifications to the web backends and the web clients. This was before AppSync was a service, so a little bit predates some of the more modern services and approaches you may use now. And lastly, another fun one is a consumer product. This one is for pet owners, so to track a pet's bathroom usage, to say it bluntly. So it's a connected device. So this is another IoT use case. But the idea here is to have these devices connected and sending information about the device as well as usage of the device to the cloud backend, which is then controlled by a mobile application. So there's real-time notifications in place here. There are messages and emails and connections to IFT and Alexa and Google Home skills. So another application that was driven off of serverless. Now if you're looking closely, you may notice on the top half of this diagram, there are a lot of servers involved. And the story here, this is a nice modernization story. When the customer first came to us, they had initially deployed this application with a previous partner who hadn't embraced serverless and hadn't embraced the IoT services in particular. And as a result, they ended up running into some pretty severe scaling challenges, especially around the holidays when their device was marketed and really selling. So we ended up coming up with an approach that bifurcated the old and new devices and took the data through the old system where we didn't have any control, and it quickly kind of merged the data streams together so that downstream all the data is handled, all the business logic is handled in one place. Over time, those legacy devices are being made obsolete, so we're hoping eventually we'll be able to shut down those old environments as well. So that's our talk today. It was really great being with you, and hopefully you found some of the lessons we've learned in our approach to serverless valuable. So thank you for joining us. We would be honored if you take some time and give us some feedback via the survey link on your screen. It's really important to us to make sure that we're making sure that these sessions are valuable and use it to drive future content. Thank you.